How do we sketch a polynomial function? In this video, I'll give you guys how do we sketch polynomial functions. In this video, we'll do 4 examples, and we also talk about their end behaviors. But this is meant to be for precalculus, so we are not going to get into too many details. So no local minimum, no local maximum. And these are the things that we are going to do. First, we are going to find the zero of the polynomial, and that's just like the same as the x-intercept, meaning that we are going to first make this equal 0 and then solve for x. So let's go ahead and get to work first. So right here we can factor out negative x squared, and then we will get x minus 2. Of course, you can also factor out just x squared. In that case, you get x squared times negative x plus 2, right? Up to you. And that's pretty much all we have to factor. And right here, we're just going to set this factor equal to 0 and likewise for that. So we get negative x squared equals 0 and the other one x minus 2 equals 0. So from here, x is 0. From here, x is 2. Alright, so again, these two right here are called the zeros of the polynomial because they will make this expression equal to 0. But in terms of the graph, they are just the x-intercept. Alright, now we are going to do a number line for the sign, and let's go ahead and put that down right here. So let's go ahead and put 0 right here and put 2 right here. And the reason for this is that we are going to figure out on what interval is this going to be positive or on what interval is going to be negative. So let's go ahead and figure it out first. To do so, first we pick a number less than 0, let's say negative 1, and then plug it into the factorative form. I think it's easier that way. So go ahead and do that. I'll show you guys all the work for the first example. We will first get negative 1 and then square and then times negative 1 minus 2. Okay, this right here is positive, but we have a negative in the front, so all in all, this right here is going to be negative. You don't have to work out the whole thing, just work out the sign, that's all we care. And then the second part right here, we have negative 3, which is of course just negative, and negative times negative, of course, that gives you positive. Alright, so we're just going to repeat the same process for the next 2 intervals. So right here, let's pick 1, because that's in between of 0 and 2. You can pick any number that you want. But anyway, put 1 here and here, we get negative 1 and then square and then 1 minus 2. First part is going to be negative, and the second part is still negative. So in fact, the second interval is still positive. And then lastly, we pick a number that says 3, or if you would like, you can put 45, up to you. Anyway though, we get negative, and then we have 3 squared times 3 minus 2, and then this is going to be negative altogether, and then the second part is actually positive now, so this times that will give you negative. Alright, so again, the zeros of the polynomial, because they will tell you the x-intercept, and the second thing is the sign chart or the number line. You just have to figure out on what interval the function is positive or negative, like that. Because if we know the function is positive, that means the graph will be above the x-axis. Likewise, if you have a negative, that means the graph will be below the x-axis. So these are the ingredients that we need. And now let's take a look at the graph. So let me put that down right here. Okay, we have 0 and 2, and they are the x-intercept. So I'm going to put it here and let's say here. And let me just do the graph in red, like so. Okay. When x is less than 0, we see that the function is positive. That means it's above the x-axis. So we're going to start up high right here, and we're just going to have a nice curve go down like this. And then you see that between 0 and 2, hey, the graph is still positive. So do not just continue the curve like this. No. We have to make sure that the curve stays positive. So you actually have to turn it back up, like so. Alright, and then you are going to just make sure that this right here turns back and hit this, right? And you might see that, hey, there is a local maximum right here, but again, we are not going to find out the x value of the local maximum. It looks like it's right in the middle, but that's not usually the case. I cannot tell you that, right? So that's pretty much what we are doing. And then lastly, when x is bigger than 2, we have to make sure that we go down below the x-axis. So just follow along like that. So this will be a very nice sketch for that. And of course, we don't really know how high this go up to, but we just care about the shape of the graph. So that's pretty much it. And finally, we'll talk about the end behaviors, meaning that when x is all the way to the left, like you see, when x is all the way to negative infinity, yeah, this piece. So let's go ahead and do that. When x is approaching negative infinity, that meaning all the way to the left, y approaches positive infinity because it's all the way up. And secondly, here we have when x is approaching positive infinity, you see that the curve goes down, right? So y approaches negative infinity. So these are the things that we will have to do. That's all. Okay, for the second one here, notice that we have 4 terms, but it's okay. Make it equal 0, and then we will factor this by grouping. So look at the first 2 terms. We see that we can factor out x squared, and then we will get x plus 3 left. And then for the second 2 terms, well, first, you see that here we have a negative. Let's go ahead and write that down right away. And then if you look at just the number, the 4 and also the 12, we can factor out the 4. But because we have the negative right here already, and then the 4, and then we have to put down parentheses, so we are already factoring out a negative 4. So originally here we have negative 4x, now it will just be x. Originally here we have negative 12, but we factor out the negative 4. And just think about negative 12 divided by negative 4, and we get positive 3. So we have a plus 3 here. Alright? And you see, this and that are the same, so we can just factor that out. It's meant to be easily factorable for this question, that's why they are the same. But anyway, we left with x squared and then minus 4, and then that's still equal to 0, of course. And notice, this right here, we can actually factor in more. So let's go ahead and do that. So x plus 3, this is just the difference of 2 squares, x squared minus 2 squares, so we get x minus, let's put on x plus 2 first, and then x minus 2. And all in all, this is equal to 0. Cool. Now, let's identify the zeros of the polynomial, or you can simply just write down the x-intercept. Okay. So, from here, we make it equal 0. We know that x has to be negative 3. And then next, from here, we make it equal to 0, so that means x has to be negative 2. And then from here, x has to be positive 2. Alright, so we have the x-intercept now. Let's go ahead and draw the number line. Let's say right here, and then we have negative 3, negative 2, and let's say 2 is right here. Now, just go ahead and do the same thing. Pick a number less than negative 3, so let's say negative 4. And you really don't have to work out too many things. I think this is the minimum that you have to do. If you do all the things in your head, then that's much easier, of course. But anyway, put negative 4 in here. Look at the first parentheses. Negative 4 plus 3 is negative 1. So you just go ahead and put down negative. Alright? That's the minimum that you have to show work. But anyway, for the next one, you put negative 4 in here. Negative 4 plus 2 is negative. And lastly, put negative 4 in here. Negative 4 minus 2 is once again negative. So altogether, we get negative for the first part. Okay, next, pick a number between this and that. Let's say negative 2.5. And then put it here, we get positive. And then put it here, we get negative. And then put it here, we get negative. So altogether, we get positive for the second interval. And then pick a number from here to here, let's say 0. And then put it here, put it here, put it here. So we get positive, positive, and then negative. Alright, so all in all, we get negative for that. And lastly, pick a number bigger than 2, let's say 3. And then put it here, put it here, put it here. We get positive, positive, positive. So, very nice. So the last piece right here is positive. Alright, so now here is going to be the sketch of the curve. So let me just draw it right here and here. Let's label the x-intercepts, which are negative 3, let's say it's right here, and let's say negative 2 is right here, and let's say 2 is right here. And of course, we have to make sure that the curve goes through these 3 points. And you can also try to label the y-intercept, which is going to be at x equals 0 and we get negative 12. But you have to be really careful though, because if you put the y-intercept here, and especially if this is in between of this and that, people tend to make it into a local minimum. In fact, it's not. So I'm not going to do the y-intercept, right? But anyway, let me just show you guys how the curve will look like. First off, we start with negative, meaning that the curve will go, below the x-axis. So start right here, somewhere right here, and then just go up, hit that x-intercept, and then from here to here, it has to be above, right? It has to be above the x-axis, so you actually have to go up like this, and then come back down to hit the x-intercept right here. And in between of negative 2 and 2 is negative, so it goes down below, so it's going to be like this. And in fact, if you check it with your graphing calculator, it's going to look like something like this. And then when x is bigger than 2, you know it's going to be above, like that. That's it. And in fact, this graph is not accurate at all, because this x-intercept right here, sorry, this y-intercept right here, it's meant to be at negative 12, but you just need to know the shape. That's all, right? Okay, now let's talk about the end behavior. So you see the left end, when x is approaching negative infinity, the curve is going downward, right? So y will be going to negative infinity. But on the other hand, when x is going to positive infinity, y will go to positive infinity. That's it. Okay. All right, for this one, we have the fourth power, but it's actually not so bad. Even though they don't have anything in common that we can factor out right away, but we can do the trinomial factoring. I will show you what I mean by that. But let's go ahead and write this down first, make it equal 0. And let me show you guys the tic-tac-toe method to factor. If you haven't seen this before, I think this is the time. But if you have your own method to factor, go ahead and do it whichever way that you prefer. Anyway, the tic-tac-toe method works perfectly when we have 3 terms. And notice that this right here is actually a quadratic in terms of x squared. What I mean by that is, you see x to the fourth power, we can factor that as x squared times x squared. And then if you look at the plus 4 right here, I'm going to write it as negative 4 times negative 1. And you see this works because when you do this times that, we get negative x squared, and when we do this times that, we get negative 4x squared. Together, they do make negative 5x squared, so we know we got it right. Yeah. So when we factor this, we actually just get, when you write down the answer, you go across. So we first have x squared minus 4, and then the other one is x squared minus 1, like so. Yeah. Okay, so it was not so bad, trust me on that. And then of course, this right here, we can factor it more just like earlier. So this is x minus 2, let's do x plus 2, and then x minus 2. And this right here, x plus 1, and then x minus 1. And that's equal to 0. So now you know the deal. Let's just label this as the x-intercept. From here, we get x is negative 2. From here, we get x is 2. From here, we get x is negative 1. And from here, we get x is 1. And here we go. Number line, right? So let's go ahead and draw a number line. And make sure you label the x-intercepts from the smallest to the biggest. So negative 2 will go first. And the next will be negative 1. And the next will be 1. And then lastly, we have the 2. All right, so let's see. When x is less than negative 2, so let's say we have negative 3. Put it here, we get negative, and then negative, and then negative, and then negative. So everything negative. But altogether, we get positive though, right? Okay, cool. And then pick a number between this and that. So let's say negative 1.5. Okay, that will be positive. So let's put down maybe right here, positive times negative, and then negative, and then negative. So altogether we get negative. Yeah, and then just continue. Let's say 0. Put 0 into here, we get positive, and then negative, and then positive, and then negative. So all in all, we actually get positive right here. Yeah, okay, good. Okay, cool. And then last one, 2 more. Let's say 1.5. And when we do that, we get positive, And by the way, it's just a good habit if you check all the intervals. Do not assume the signs will alternate, because if you look at the first one, part A, yeah, it was positive, positive, negative, right? So be really careful. Was it negative? It was, sorry. It was, yeah, the sign didn't change for the first two intervals. Just check out part A. But anyway, 1.5 into here is positive, and then we get negative, and then positive, and then positive. So all in all, we get negative. And lastly, let's say 3, positive everybody, right? So positive, 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 and of course, just positive. All right, so we have 5 intervals. That's quite crazy. But anyway, have a look right here. So let's see. Let's put negative 2 right here, and let's say this is negative 1, and let's say this is 1, and let's say this is 2. And of course, these are the x-intercepts. Here we go. Positive, meaning that we start up high right here, and then we just kind of go down. All right, and hit the x-intercept, and then between this and that, we have to make sure we go below the x-axis. So let's just go below, like so. And then we have to come back up, right, to negative 1. And then from negative 1 to 1 is positive, so I'm just going to go up like this to somewhere, and then I have to come back down to hit the 1. And then from 1 to 2 is negative, so I will just have to go like this. And in fact, this right here is actually an even function. You can check that. So just make it symmetrical. That will be really nice. And then lastly, after 2, this is going to be positive, so it's going to be like that. And as a little bonus, we can also add the y-intercept. If you put 0 here, put 0 here, of course you end up with 4. So lastly here, this right here is when y is equal to 4. All right, so let's see. When x is approaching negative infinity, this right here, the y value will go to positive infinity. And on the other hand, when x is approaching positive infinity, y will go to positive infinity as well. And that's the graph for it. Okay, take a look at part D, and of course, let's go ahead and just make this equal 0. Well, the factoring right here is that we are going to factor out the x squared first. So let's go ahead and make that happen. And then from there, we get x squared, and then minus 3x, and then minus 4. Yeah, because they all have the x squared, so we must do that first. All right, this is equal to 0. And right here, you can do the tic-tac-toe, but this is not so bad. We can see that we get x squared, and we just have x minus 4 times x plus 1. And that's equal to 0. All right, so now let's go ahead and find the zeros or the x-intercepts. For the first thing right here, we just get x is equal to 0, and then next we get x is equal to 4, and lastly we get x is equal to negative 1. All right, so now number line. Let's go ahead and put that down right here. Negative 1 will go first, next will be 0, and then lastly we have the 4. Pick a number less than negative 1, let's say negative 2. Put it here, we get positive, because x squared is always positive. And then put it here, we get negative, and then negative. So altogether, we get positive. All right, pick a number between this and that, let's say negative 0.5. This is, again, positive, and then we get negative, and then we get positive. So altogether, we actually get negative. All right, pick a number between here and here, let's say 1. Put it here, we get positive. Put it here, we get negative, and then put it here, we get positive. So right here, aha, you see? The sign didn't change, negative, negative. And the trick is, yeah, you know, the power, right? Here we have even power, so be really careful whenever we have the even power. Okay, lastly, let's say 5. Put it here, 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 and here, we just get positive, positive, positive. So of course, this is just positive. Okay, so here we go. Let's go ahead and sketch the graph. Here we have negative 1, and then let's say 0 is here, and let's say 4 is somewhere here. And of course, again, they are the x-intercepts. So go ahead and mark these points. Firstly, we have to make sure that the graph starts above the x-axis. So let's go ahead and start right here. Come back down, hit this, good. And then in between of negative 1 and 0, it's negative. So we have to go down and then come back up to hit the 0. But after 0, hey, the graph will have to stay below the x-axis because we get negative. So we just have to compile it down like this to somewhere. It's not in the middle, right? It's not necessarily in the middle, but I don't know. I'm just going to compile it down like this and then turn back up to hit the 4. Once again, the local minimum here is not necessary at 2 because that's no, we don't know, but this is okay. Anyway, lastly, after 4 it's positive, so I'm just going to go up like that. So that will be a picture for it. And of course, that's also the y-intercept, so nothing too much we can talk about. And we will just finally say, when x is approaching negative infinity, this end, y goes to positive infinity. And on the other end, when x is approaching positive infinity, y goes to positive infinity. So that will do it.